Press the wrong one. Okay. Alright guys, let's do magnetism TYS now. So can you take out your topical TYS and turn to this page, alright, on magnetism. I think it's page 20/1. Alright. And then we have a very kind gentleman who gave me a very clean TYS that doesn't seem to have done already. Okay class, I have two ways of going through it. Either I go through the tough questions or I go through every question. Which one do you want? Some question, Alright, question number 1, do you need help? Yes or no? 5, 4, 3, 2, 1. No need, How about question number 2? Do you need help for question number 2? Also no need help, So clever, Huh? Question 3, Okay, let's go to question 3 now. Okay, question number 3, alright. 4 plotting compasses are placed near a bar magnet. You may ignore any effects of the Earth's magnetic field. One compass appears like this, that, okay. What is the possible position of the compass? Now remember, number 1, you must remember that the compass needle always points in the direction of the magnetic field. I repeat, the compass needle always point in the direction of the magnetic field. So because the compass needle always points in the direction of magnetic field, what you do is, the easiest thing you can do is to draw the magnetic field on the question paper itself. So you're going to draw the magnetic field. The first field is this guy here, then it's going to go like that. Okay, this is the first thing. So the magnetic field always go from north to south. So you know that A is going in this direction. Alright, this is the direction of A, which is not the direction we want. How about B? B is right smack in the middle, so it will get the central magnetic field line, the one that divides the top and the bottom. So B is going to the right. Again, B is not the magnetic field that you want. Alright? That leaves you with C and D. So the option becomes a lot easier. Alright? So sorry, the C and D looks like a different field. So the C will be obviously the choice because the C, the field is going this way, while D is going this way. So the answer is C. Okay, So what's the next question?
5.
Question 5, Okay, remember, it's always how the field, always the direction that the magnetic field points. So always draw the magnetic field lines, and the direction at that point that you move is the direction that the compass will point. Okay, are you ready? Can I go to 5 now? Okay, question 5. Alright, the diagram shows a magnetic field pattern due to a current in the solenoid. Which statement is correct? The strength of the field is greater at K than that is at L. Now, remember, for magnetic field pattern, alright, closer lines means what? Closer lines means what? Stronger magnetic field. So further lines means what? Weaker. Now class, can you tell me at which point do you think is the strongest? Okay, let's take one step backwards. At which point do you think is the closest lines? M, correct. M is the closest line. So actually at M, the field is the strongest. And in which point is it the weakest? K, okay. So let's read the question now. The strength of the field is greater at M than at L. Voila, that's the answer. I don't even read the rest. Okay, don't believe, we can read the rest, alright? Greater at K than L, rubbish, alright, K is definitely weaker than L. is the same as K and M? No, M is strongest. Okay, it's the same as L and M. Rubbish. M is the strongest. So the answer is B. Alright guys, next question. Next question. Question 6. Any problem? No? Yes or no? No. Question 7. Any question? Any problem? Question 8. Question 9. No. Question 10. No. Simple. Magnetism is easy. Alright. Do you need me to draw the magnetic field? No. I think if I have to draw the magnetic field, there's something wrong with you. Okay. So we shall not draw the magnetic field. But do you know how to answer this question? The north pole of magnet A repels the north pole of magnet B. Okay, but attracts the south pole of magnet B. Explain why magnet B still move away from A. Do you understand how to do this? I actually explained to the class several times. Okay, anybody want to try this? What do you think is the answer? What do you think is the answer? Kayasha, what do you think is the answer? Do you know what they are saying? It's like they are asking you A, the north pole here repels this. North repels north. But the north pole here attracts this, the south. But why is it that the two are still repelled? One attract, one repel, but how come ultimately repel wins? Any idea? Yes, the force of repulsion is greater, but that alone is not enough. You must have a keyword. What's that keyword? Distance. The distance between the north of A and the south of B is further than the distance between the north of A and the north of B. So the force of repulsion is greater than the force of attraction. Do you need me to write down? No need. The answer key behind is good enough. So I will just read it out. I hope your friends watching this video will be able to understand. Okay, draw the magnetic field lines. Okay, this one I don't want to go through already. Alright, question 2. Any problem or not? Question 2, any problem? The lines near X are parallel and evenly spaced. State what it shows about the magnetic field. Okay, this is a very, very interesting question. I believe if you have never seen the answer, you probably also don't know how to answer this. Now, how many of you will think that the answer is, it shows that the magnetic field is strong. Stronger. But the truth is this, when you look carefully, they did not say that the lines near X is closer together. They didn't say that. What did they say? Parallel and evenly spaced. So they are not asking about strength. They are asking something else. Ask you, remember just now we mentioned lines closer, magnetic field is stronger. Lines further, magnetic field is weaker. Now, what's the distance between the two lines here? Is this distance okay, D, okay, don't know how much. What's the distance here? What's the distance here? If the distance is always the same, what can you say about the magnetic field? Uniform. They are looking for the word uniform. Understand? So be careful. O-level is actually easy, but they like to ask out of the box questions that you usually don't see in textbook. Alright, so this question is asking for the keyword uniform. I'm just going to write the keyword here. Alright, I'm just going to write the keyword here. The keyword is uniform. Alright. The lines near Y are further apart. State what does this show. Now, class, this is where they are asking for the strength of the field. Understand? Because now they are saying the golden word further. So when you see this word further, the answer is, I'm going to write the keyword. What's the answer? Weaker. Correct. I'm just going to write the keyword here, nothing more. State what is meant by the north pole of a bar magnet. Okay, wow, my goodness. Why O-level so annoying one? When I ask this question, right, it's like, duh. I thought this is like no-brainer. Everybody knows. Why must they ask this? Welcome to O-level. Okay, then you'll say, teacher, how do I answer this? Now, guys, how do you answer this?
The red colored side of the bar magnet.
It's the red color side of the bar magnet. Wow, what the answer? What if they decide in another country, right? Red color is south, how? Okay, is there an the side where there's an N painted on it? Yes. Okay, it's a site where it is called North Pole. They already say North Pole. Win already, lor. Are you telling me something more than that? What else? When you suspend the magnet, what happened to the North Pole? So what they want to ask is the most fundamental question. How do they define North Pole? Do you remember how they define North Pole? They define North Pole as the side of the magnet that points to the, okay, let's be very, very scientific, geographic north. No, magnetic south, geographic north. Remember? Our North Pole is South Pole, ma. Remember that? Hey, don't blur. I thought you already. So guys, how would I tackle this answer is I will just write it this way. Side of magnet that points, side of magnet that points to the geographic north when freely suspended. See how elegant and how efficient use of words. All right, you must use words very efficiently in O level, huh? And then you found something interesting. Wow, Mr. Low, are you sure or not? This type of question also have. See, you memorize, regurgitate, you got full mark already. How do you demagnetize a bar magnet? Do you need me to go through this? Remember, what's the key? Okay, you all write this thing down first. Write this thing down first. But what's the key points that you need to stress here? I have a coil. I have a bar magnet. Then you put together. But then, that's only one mark. I have a coil, I have a bar magnet, put together, one mark. What's the second mark? I have a current, but it's DC or AC?
AC.
The key is AC, but not enough, still half a mark. Pull out in the what direction? Pull out in the what direction? East-west direction, or like a Royston like to say west-east is okay. You put west-east, you will still get the marks. Okay, pull out in the east-west or west-east direction. Why not north-south? Because if you pull out in the north-south direction, there is a very annoying magnetic field that will still remagnetize the bar magnet, and the annoying magnetic field is the Earth magnetic field. Alright, understand? So that's why you cannot pull out in the north-south direction. So there are 4 points. You must have a coil, you must have a bar magnet, you must have an AC current, and you must have pulling out in the east-west direction. These 4 points. Alright guys, this question that you are seeing now is actually a electromagnetism question, alright, but never mind, we will do it together. Okay. Fantastic, we have 2 questions left. This is good. A student construct a model of a circuit breaker using an unmagnetized steel core. Now guys, when you read this question, straight away when you see a certain word, it must ring a bell in your brain. What's that certain word? Steel. You never steal a question with steel. Alright? Never, ever, ever in O level will you have a steel core, a steel something inside. Steel is only used for permanent magnet. That means that the core must always be iron core. So when you see the word steel, straight away, I know the question already. Confirm is that question. Okay, they will ask, why is it that cannot work? Or why is it that it switch on, cannot switch off? Okay, so let's read the question. The circuit breaker is connected to a series with a circuit using P and Q. A current in the circuit causes the contact to separate. Explain why. Now this first part is easy, alright? Can you explain why? When there's a current through P and Q, what happens? You'll flow like that, then you'll flow like that, then you flow like that, then come out. So means what? This whole thing becomes a, when this whole thing becomes a magnet, what happens? It attracts. Okay, so first point, 1 mark, how do you score it? So you say that the coil is magnetized by the current, and what happens? Attracts the iron core arm and separate the contacts. Alright, so that's that. But this is not the most important part. The most important part is the next question, alright? A circuit breaker has advantages when compared to a fuse. One of the advantages is that it can normally be used more than once. The student finds that his model can only be used once. Alright, so just explain the reason why. So once you see the word still, you know that there's this magical question coming out that you're going to score full marks. Are you happy with it? It's like they want you to steal the marks. Alright, so can you explain how? So remember, once you have steel, what is steel compared to iron? Iron is a soft magnetic material, steel is a... Which one is soft and hard? Iron or steel is soft and hard? Steel is hard magnetic material. What is hard magnetic material? So the first mark is you must just state the characteristic of the steel. Steel core is a hard magnetic material that cannot be easily magnetized or demagnetized. After that, what must you say? So the So this is the answer. Okay, I hope you can see. So what happened is that in part 1, the steel core is already magnetized. So the steel core that is already magnetized will continue to attract the arm. So when you continue to attract the arm, what happens is that the contact remains open. So when the contact remains open, there is no current, and so it cannot be reused. Understand? So now it's 2:51. We are coming to the last question. Amazing. We are at exactly the right time. Okay, I'll give you some time to do this question now. Oh, the next question is damn easy. Okay, the next question is just drawing the magnetic field pattern, so I will stop here. Alright, so that's all.